The topic for this video lecture is timer programming of 8051 microcontroller. So where we will be learning about the timers present in 8051 and the associated registers and how to program the timer in different modes of operation. And this is Dr. S. Mohan Lakshmi, Professor and Head, Department of ECE from Rohini College of Engineering and Technology, Kanyakumari District. So on completion, the learners will be able to list the timers of 8051 and their associated register. They will be able to describe the various modes of 8051 timers, and they will be able to program the timers in different modes, say for example, the generation of time delays. So before going into the programming aspect, we will see what are the registers associated. So we know that 8051 has two timers. We name it as timer 0 and timer 1. And each timer is associated with a register called a timer register, which is of 16-bit wide. And this can be splitted into lower byte register and the higher byte register. Say for example, if it is for timer 0, we denote it as TL0 for lower byte and TH0 for higher byte. Similarly, for timer 1, we give it as TL1 and TH1 respectively. And the very important thing is it can be accessed like any other register. And here we can see the representation of these timer register, where it is mentioned as timer lower register and timer higher register. And this is splitted into 2 bytes, that is TL and TH respectively for timer 0 and timer 1. And the second register associated with the timer is timer mode register. And here it is an 8-bit register where the last 4 bits, that lower nibble is associated with timer 0 and the upper nibble is associated with timer 1. So in both the cases, the last 2 bits represent the mode of operation. In the combination like 0 0, it is mode 0, which is a 13-bit timer mode. 0 1, it is a 16-bit timer mode. And 1 0, it is an 8-bit timer mode, which has an auto reload facility. And 1 1, which is a mode 3, which is a split timer mode. And the first 2 bits, the first bit represents the gate signal. So whether you're going to trigger it by hardware or software, and preferably we do it with the software. And the second bit, which tells you that whether you're going to choose this timer as a counter or a timer. Whenever this bit is set, it will act as a counter. Whenever this bit is not set, it will act as a timer. And what is the clock source for the timer? So every timer needs a clock pulse to tick. So if counter slash T bar is equal to 0, then the crystal frequency attached to the 8051 is the source of the clock for the timer. So normally this frequency for the timer is always 1/12 of the frequency of the crystal attached to the 8051. So 8051 normally it comes with the external frequency to be 11.0592 megahertz, which allows the 8051 system to communicate with the PC with no errors. And we'll see the programming aspect. So the main thing we are going to concentrate on mode 1 programming and mode 2 programming. So mode 1 programming. So mode 1 programming, as I've told you, the mode 1 is nothing but it is a 16-bit timer mode. So what we need to do is the 16-bit count need to be loaded in the timer register, and this initial value will be loaded in TH and TL, and once the timer is started, the timer counts up until it reaches its final limit, which is F F F F, and once it reaches final limit and rolls down to 0 0 0 0, the timer flag TFX will be set. So when the timer flag is raised, we can stop the timer by the software or by writing the instruction clear TRX. After the timer reaches its limit, it rolls over and the registers must be reloaded again. That is, TH and TL has to be reloaded again with the original value if you want to continue. And the TFX must be reset to 0. So this is a representation of timer 0 with external input in mode 1. So you can see here there is a timer 0 external input at pin 3.4, and we have given counter slash T bar either as 1 or a 0. So if it is going to be 0, this will act as a timer. And here this TH naught and TL naught will be given some initial count, and once the timer starts, it will count till the final count FF and it will roll down to 0. Once this is rolling down to 0, the timer flag, which we represent here as overflow flag, will be set. If it is for timer 0, it is TF0, and if it is for timer 1, it is TF1, which you can see here in this diagram representation. Only thing, the external input what we need to give in the timer 1 is at 3.5. And what are the steps that we need to program in case we are going to program it for mode 1? So first thing is we should load the TMOD such that we select the mode of operation to be mode 1. Next step is like you have to load the count, 16-bit count, initial count with the timer register. Then we have to start the timer usually by writing an instruction set bit TRX, and we have to monitor the timer flag until it is raised again with the instruction JNB TFX. And once the TFX is raised, we have to come out of the loop. We have to clear the timer flag, clear the timer itself, and in order to repeat, we have to go back to step 2 in order to reload the count. So here one example I have given, which is an assembly language programming to generate a delay of 10 millisecond. So as the first step, we are loading the TMOD with the timer 0, which is in mode 1, which is a 16-bit timer mode, and we are loading the count, say DC 00, and we have to start the timer. Then you have to monitor the flag. So as it is a timer 0, we are monitoring TF0. And once the timer flag is set, we have to stop the timer, clear the timer flag, and we need to repeat the process if you want. And similarly, you can see here there is a generation of a square wave of 5 kilohertz frequency at port pin P1.0, and the given clock frequency of the 8051 is 11.0592 megahertz. So again here we have to load the TMOD, load the count, we have to start the timer. Then one thing what we have to do is, as we need to generate a square wave at port pin P1.0, we need to complement, or you can set it and clear it with a delay. So we are setting, we are complementing it, the P1.0, and once if it is going to be 0, this will go to 1. If it is 1, it will go to 0. And once the flag is raised, a delay will be generated. And again we have to repeat the process of complementing. So we have to stop the timer, we have to clear the timer flag, then again we have to short jump again. Then finding the values, what values to be loaded in the timer register. Finding the values to be loaded into the timer. So say for example, if we have the external frequency to be 11.0592 megahertz, we have to divide the desired time delay by 1.085 microsecond to get n. As it is a 16-bit timer, subtract this value n from 65536, which is the decimal equivalent of FFFF. So we will get a value which we denoted here as a capital N. So convert this n into hex character or hexa equivalent, which we represent as YYXX, where YY has to be loaded in the higher register of the timer and XS should be loaded in the lower register of the timer. So this is how the value to be loaded in the timer register. And say for example, here one example I have given. So find the count to be loaded in the timer register to generate a square wave of 50 Hz frequency. So here it is timer T I have taken as 1 by 50 hertz, which is 20 millisecond, as it is going to be a square wave. So we have T on plus T off is equal to 20 millisecond. So we need to generate a pulse or a lower portion of 10 millisecond, higher portion of 10 millisecond. So the desired delay is, now we know that it is 10 millisecond. So as I told you in the previous slide, divide the desired delay by 1.085 microsecond. So I get the count to be 9216. So subtract this from 65536, where we get the count to be 56320 in decimal. So convert that into hex, we get it as DC00. So that should be loaded in the TH and TL registers. So suppose I want to generate a time delay. So the delay depends on the crystal frequency and the 16-bit register in mode 1. So it can be achieved by making both the registers TH and TL to be 0. So I get the initial count. I start with the initial count to be 0, 0, 0. So obviously it takes 65536 to plus 1 to go for a timer flag to be set. So we get a larger time delay. This is one possibility of generating a larger time delay. And coming to the next mode, which is a mode 0, it is very similar to mode 1, except that instead of loading a 16-bit count, we load a 13-bit count. And here this can hold a value right from 0000 to 1FFF. So when the timer reaches its maximum 1FFF, it will roll over and the timer flag will be set. Nothing more else about mode 0. And coming to mode 2 programming, it is also similar to the previous two mode of operation, except that it is an 8-bit timer and it has an auto reload facility. So the whatever value you want to give it as a count, it should be loaded in the THX and a copy of it will be given to the TLX. So the timer, as usual, it is started by set bit TRX, and once the timer starts, it starts incrementing the TLX register. So once it reaches the final count, which is FF over here, then it will roll down to 0. The timer flag will be set. So here the main difference between the previous modes and this one is like we no need to reload the count. Okay, so the count will be automatically reloaded in the TLX from the THX. So to repeat the process, essentially we need to clear the timer flag. So these are the steps we need to do for programming in mode 2. So as usual, you have to load the TMOD to select mode 2 and the timers. Load the TH value. You no need to load TLX. It is enough if you load the THX. Start the timer. Monitor the flag. Get out of the loop when the flag is raised. And obviously we have to clear the flag, and suppose we need to go for continuous process, we have to go to step 4, just monitoring the timer flag, as it is a auto reload mode. So this is you can see here the same thing, timer 0 with external input. This is for timer 0 with external input for mode 2, and here you can see TH0, which gives a copy of it to TL0. So once the it reaches the final count FF and roll down to 0, the overflow flag will be raised. So similarly for mode 2, which is for timer 1. So the very same thing, except that we give the external input in pin 3.5 and the timer flag 1 is raised. So another register which is associated with the timer is TCON register. So in all the previous programming aspect, I told you about setting the TRX or the start the timer with set bit TRX. But where are these registers present? So it is actually present in a register called as a timer control register. And similarly, the flag which I mentioned earlier, which is a TF1 or TF0, is again present in the TCON register. So here the TR0 and TR1 flags turn on or off the timers. So it is a part of a TCON, which is a timer control register. So normally the upper 4 bits of TCON register will use to store the TF and TR bits of both timer 0 and timer 1. And the lower bits are set aside for the interrupt. So that's what can say here, set bit TR1 or clear TR1 by using the instruction straightly, or I can very clearly specify set bit TCON.6 or clear TCON.6, which means that it is the sixth bit of the TCON register, which is bit addressable, and it comes under the category of special function register. So this is the equivalent instructions for the timer control register. As I mentioned here, set bit TR0, clear TR0, similarly timer flag, setting and clearing, and similarly for timer 1. So the first 4 bits represent for the timer bits, which is TF1, TR1, TF0, TR0. So very equivalently we can set on the clear by giving an instruction set bit clear the respective bit addressable bits TCON.4 or 5 or 6 or 7 respectively, seeing from this slide. And the possible assessment questions on 8051 timer programming will be like, so what will be the equivalent of the following instruction, which we have seen in the last slide, or they'll be able, you will be asked to find out the frequency and period using the crystal of finding these values. So what is the frequency, what is the period, and similarly you will be asked to write the programs for generation of the delay, okay, either in mode 1 or mode 2 or even in mode 0. Okay, and or you will be asked to generate normally the waveform generation, square wave generation. They will give certain frequencies, and you need to find out what is the desired delay we require, and we need to find out what is the count we need to load in the timer registers, either it's for 8-bit or 16-bit or 13-bit, and this has to be then the program has to be written as usual. Thank you.